Alright, so we are investigating similarities. So first we have this triangle right here, ABCD. Point A is at 0, 0. Point B is at 0, 8. Point C is at 6, 0. Alright, so now here we have our triangle. So we're going to find the measures of the angles and the sides of this triangle. Let's start with the sides. So side AB, easy enough to find the measure. We can just count. 1, 2, 3, 4, 5, 6, 7, 8. 8 units. Side AC, it's a straight line, so we should be able to count the units. So we have 1, 2, 3, 4, 5, 6 units. But how am I going to find B to C? If you're yelling out Pythagorean theorem, you are correct. Remember, Pythagorean theorem is a squared plus b squared equals c squared. Remember, our legs are A and B. Well, how do I know I can use this? Well, this is a right triangle, and I know this because my x and y axis create a 90-degree angle because they are perpendicular to one another. So I can use the Pythagorean theorem, and this is C. That's what we're looking for. So we know the measures of A and B, which is 8 squared plus 6 squared equals C squared. 8 squared is 64 plus 6 squared, which is 36, which equals C squared. Well, if I add these two together, that is 100. 100 equals C squared. Now, I just want to know what C is, this distance. I don't need C squared. So how do I undo that? I find the square root. And the square root of 100 is 10. So BC is 10. Alright, so there are my measurements of each side of this triangle. Now let's find the measures of each angle. Well, we know that angle A is 90 degrees. Angle B, I'm going to have to measure angle B. So I'm going to use my protractor here, and I can see, I'm going to swing, it's not long enough. I can see that's about 30, whoops, I'm not on there, there we go. About, let's see, this is 30, this is 35, I'm going to say about 37 degrees. Now, once we have one angle, we should be able to get the other by subtracting, because all three angles of a triangle equals 180. So 180 minus 90, whoops, that's 480. 180 minus 90 equals, and then minus 37. So my third angle should be 53 degrees. But let's measure it just in case. So put my dot on the vertex, and what do you know? It is 53 degrees. Alright, so now I have, make sure this is, there we go. It didn't look like it wasn't focused enough. So now we have all the measurements. So what are we going to do with this? Well, we're going to go on and we're going to make another triangle. And it wants us to dilate triangle ABC, so this one here, by a scale factor of 1/2. And we're going to draw the image on the second coordinate plane and label the image A prime, B prime, B, C prime. So let's do that. Now that means I'm going to multiply each one of these numbers by 1/2. So half of 0 is still 0, so that A prime is still going to be at 0, 0. A prime. Then 0, 8, well 0, half of 0 is 0, but half of 8 is 4. So B prime is 0, 4, so it's going to be right here, and that's B prime. Now C prime, half of 6 is 3 and half of 0 is still 0. So here is my C prime. Really, the only 2 points I have to connect are B and C, and I'm going to use a straight edge for that. So here is my A prime, B prime, C prime triangle. Let's find the measures of the sides. So what's A prime to B prime? A to B is 4. A to C is 3. What do we have to use to find B to C this time? And can you predict what it might be? So we're going to use Pythagorean theorem again. A squared plus B squared equals C squared. This time A is 4. B is 3. And now I have to solve for C squared. So 16 plus 9 is C squared. 16 plus 9 is 25. And remember what we need to do here to get C by itself? We need to find the square root. So square root of 25 is 5. You can put that in your calculator if you need to. And the square root of C squared is just C. So B to C is 5. I don't know if you're noticing anything yet. Any pattern. If you are, good. Alright, so again, we know A prime is 90 degrees still. That did not change. Let's see about, I'm going to do C this time first. Oh, this protractor is going to get on my nerves. So if I'm going to extend this line just because I want to. So I can find the measure. There's better ones than this, better compasses than this, but that's just what I'm going to do. Okay. So I'm going to look at the outside, and it says 51, 2, 3, 53, right? 1, 2, 3. So C prime is 53 degrees. And then B prime, well, I'm not going to, it should be the same. Let's see, 180, again, 180 minus 90 equals, and then minus 53 gives us 37 degrees. Huh, are we noticing anything? So remember, we dilated the first triangle ABC to triangle A prime, B prime, C prime by halving it. And if you notice that our angles are the same, but our sides, the distance of our sides are not. And we'll talk about, and they are halved. Well, now we're going to make a ratio of our image over our pre-image. So for our image, A to B is 4. Over our pre-image, AB is 8. And that reduces down to 1/2. Let's see if that happens again with A to C. A to C for our image is 3. And AC is 6. And again, that reduces down to 1/2. Now, B prime, C prime, this time, remember, it was 5 for our image, but for our pre-image, it was 10. And that, too, is 1/2. Where did we see that 1/2 before? Oh, yeah, that was our dilation, was 1/2. And so our sides have a ratio of 1/2 as well. So this is what it all comes down to. In similar figures, all corresponding angles, so that means the measure of A and the measure of A prime, the measure of B, the measure of B prime, the measure of C, the measure of C prime, they are all congruent. So all angles of similar figures, all angles and their corresponding are congruent. All corresponding sides, though, are all corresponding sides congruent? Let's see. A to B, A to B. No, they were not congruent. But they are proportional. What does that mean to be proportional? That means they all can reduce down to the same fraction like we see up here. Like all of our corresponding sides reduce down to 1/2. So we can also say have the same ratio. They have the same ratio. So all corresponding sides are proportional, as it shows here. This is also the dilation. We say triangle ABC is similar to triangle A prime, B prime, C prime. This is how you would write it. And that is it. Now you're going to practice.